Hi everyone, Dr. J here, and in this video I'm going to introduce you to the basics of the Python programming language. Now Python, as I've said, is a very widely used and popular programming language for a whole number of different things, including machine learning and data science, website building, scientific applications, and a whole host of other things as well. And in this lesson we're just going to learn some of the basics to get us started on the basic syntax and data types and things like that. Now, what I recommend for this video is that while you're watching is that you have this Google Colab notebook open in one window of your web browser, and then have the video playing either on the side or in the background. And as I go through the notebook, you can follow along in the actual notebook yourself and go through the code and run all the examples and so forth. So that's how I recommend to go through with me. So the way that we're using Python here in this example is called a notebook. And a notebook is just a way to run Python from a web browser. Now the most common way to do this is actually from what's called a Jupyter notebook. But this is a very similar version to that, which is used in Google Colab, which we are in right now. And so this is called a Colab notebook. And actually Colab can run Jupyter notebooks or Colab notebooks as well. And we'll be using both in this class. Just to get started talking about Python, it's a popular programming language that is reliable and flexible, easy to learn. One of the, if not the most easiest, one of the very easiest languages to learn. Free to use on all operating platforms and supported by a strong developer community, and has a lot of different packages and modules that you can install and use. As I said, doing everything from building large machine learning models to doing front-end web development to doing very basic, simple stuff like fitting lines and calculating, just doing basic algebra or basic math, and all sorts of things for universities, scientists, professionals, all kinds of things. You can even generate music and art using Python. So what we'll do is we'll just start talking about what the language is and how to use it. Now, one note, as I say here, there's historically a little bit of an issue because Python 2 was used in the past, and a lot of programs are still written in Python 2. But the modern version is Python 3, and we'll be using Python 3 in this class, and that's basically what you'll end up using in the future because Python 2 is getting slowly phased out over time. Now, we've already talked about what is a programming language, and Python in particular is what's called an interpreted language. What this means is that we can actually run code directly, and we don't have to do any intermediate steps. So a compiled language would be the alternative, and that would be something like C++ or C# or Java. Those are languages that have to be compiled after you write them and before you can run them. In comparison, we can literally write Python code and then run it right away, and that's what we're going to do in this notebook. One thing that I mentioned here is about comments, and comments start with a hash character. And these comments are anything that you can write anything you want inside of a comment, and that is just extra text. You're not going to run those lines. And so here's some examples of some comments. You can see we have a text in this cell, and these individual units are called cells in notebooks. You can see I have a little play button here, which lets me run the contents of this cell. And you can see that there's a comment here. Here's a comment following a declaration of a variable. That's my variable there. Another comment without a variable, and again another variable declaration. And you notice here this says this is not a comment because it's inside quotes. So here we're declaring the variable to include a string inside quotes, and inside those quotes we have this hash symbol, but because it's inside the quotes and it's being assigned to a variable, it's not going to be a comment. And we can actually print that variable, and we'll talk more about that in a second. And we can just run this notebook. You might get this warning note from Google saying that the notebook was not authored by Google. That's okay, you can run it anyway. And here we go. So we run it, and what is the output of this cell? The output of this cell is printed here. And it's printing the text of this message. This is not a comment because it's inside quotes. Now, just to work a little bit more within the cell to give you an idea of what's happening, within the cell we're defining two different variables, spam and text. And if we actually highlight, or I should say hover over this variable, Google Colab will tell us what is the name of the variable, that's spam, what is the data type, and you can see the letters int, that stands for int, which is short for integer, and then the value of this variable is 1. So we're assigning an integer 1 to the variable named spam. And then once we've done that, that variable exists. So it exists now because we've run the cell, but you don't see that variable printed out anywhere here, and that's because we didn't ask to print that variable. We only asked to print the variable text. In this case, text is a variable. You can see that the data type there at the top is str, and that is short for string. And the reason that, or I should say, a string is a sequence of characters. Basically, it's just text. And you can see that that is there as well. And then you can see the value of the string. And then we're printing the text variable, which is why we get this line here. This is not a comment because it's inside quotes. Now, if I were to change this to print spam instead of text, we would get the number 1. And we can also look at the type of spam. So I'll say print type spam. And you can see here I'm using, in each case, I'm using what's called a function. This word type is referring to a Python function which returns the type of a variable. And in this case, the variable is spam. And then I'm going to print that. So in each case, I'm using open close parentheses to pass an argument to a function. So let me just get rid of this here for a second. Let's look at this line again. I am taking the variable spam, that is an integer with a value of 1, and I'm passing it to a function called print by putting the variable inside these open close parentheses that are right next to this function print. And again, I can run that. And then let me put back in this printing the type of spam. And now we've printed both the value of spam and the type of spam. And you can see that spam is of class int. So we already said that spam was an integer, and so that is called an int. And when it says class, all things in Python are called objects. And an object is something that's a very generic term for something which can be a lot of different things. So obviously an object can be an int. We can actually, let's do this with the variable text, and let's see what kind of type that is. So here's again our text comment. This is not a comment because it's inside quotes. And then you can see the type is class string. So a class is essentially a definition of a type. So you can see this case is class string. Before we had class int. So a class is basically defining what a data type is and what it can do. Now we'll probably get into a little bit more about classes and objects, but for now I'll just say that everything in Python is an object, and an object is an instance of a class. So classes are kind of the definitions. So with the class integer, or int as it's abbreviated, there's a whole set of definitions associated with that. What it can be like. For example, an integer doesn't have any decimal places. An integer is a number, and so on and so forth. So all of those rules are associated with a particular class, and now we've assigned this variable spam to have a value of 1. 1 is an object because it's an instance of the class int, and now actually spam is also an instance of the class int, and so spam is also an object, which is one instance of the class of type int. So if that's a little bit confusing, that's okay. We'll talk more about that later. But for now, just keep in mind that everything in Python is an object, and classes are simply the definition of what it means to be an int, or in the case of text, what it means to be a string, or what it means to be whatever type of class that object happens to be. And there are many different types or classes of objects, and we can actually define our own classes and so on and so forth, and we'll do that later on. So, but let's go on and let's stick with the basics for now. Let's try to explore some commands that look at numbers and strings and lists. You can use Python basically as a very simple calculator. So this is one very easy way to use Python, and you can see we've got this expression here, 2 plus 2. We can run this cell and we get 4. And let's just quickly look at the type of 2 plus 2. So notice now I'm passing in not just a single variable to this function, but actually a whole expression, 2 plus 2. And let's look and see what this gives us. So notice here that I'm not using the word print. So if I get rid of this type expression and I run the code cell, it gives us 4. So it basically automatically by default prints out the last line. If I put in type of 2 plus 2 and run that, it's going to give us, again, the last line in the cell. But if I put print on both of these statements, then it will give us both of those statements. It'll print out both. So 2 plus 2 is 4, and the type of 2 plus 2 is a class int. And why is that? Because class int is the class of 4. 4 is an integer, and so what we've done here is we've actually set up kind of a nested expression where we are passing in 2 plus 2, and that's going to get evaluated, and the result, which is 4, passed into the actual function itself. So just like, let's get rid of these print statements here. So if we say print 2 plus 2, that gives us 4. If we say type 2 plus 2, that gives us the type of 2 plus 2, and that's an int or an integer. We can say any other function, and let me think here. I can say list 2 plus 2, and we have an error. So list is a function in Python, but what does it say here? Int object is not iterable. So this is a good time to start introducing errors. And errors are going to be very common companions to you as you are learning how to program. So here we're just playing around, experimenting with this code cell. We put in a function which we know is an actual legitimate function, and then we've gotten an error. And what is this error? The way that you need to handle errors in Python is this way. First of all, you want to look at the main error message. And usually in Python, it'll give you a whole lot of information here. You can see that we only have 2 lines of code here, but there's actually 1, 2, 3, 4, 5. There's more than twice as many lines of code relating to this error that we even have code. And so you can imagine when you start getting into more complicated code examples, the number of lines relating to the error message is going to get really complex. But what you need to find is the main message. And usually, the main message is at the very end. It's the very last thing printed out. Type error, int object is not iterable. And here's where we can start to use some of the information that I've already given you. So first of all, type error. We know that we've just been looking at types of objects in Python. And the type of 2 plus 2 we've already seen was an int. And that makes sense because it says right here, int object. What is an object? Remember what I said, everything in Python is an object. And an object is an instance of a class. So all this means is saying that we've defined something which is of class int. And so that definition, that particular instance of that int is an object. And it's saying that this particular int object, which just happens to be the output or the result of 2 plus 2, is not iterable. So let's come back here. First of all, let's say type 2 plus 2. That's an int. So it's saying that the object that we're actually getting, and let's do it this way. Let's break this up into 2 steps. So we'll say example object equals 2 plus 2. And now we're doing the same thing as we were doing before, and we get the same result as before. But now we've just assigned this 2 plus 2 to a variable, called that example object. And now we're getting the type of that example object, which is an integer. So everything here is the same as it has been for us. But now when we're trying to do list of example object, we get this error message. Int object is not iterable. We can't, and again, we're looking here at the main error message. So we're not necessarily looking at anything up here, except for the fact that it does help us to see where the error occurred. So we do see at the top, we see the type error, so that's the same kind of error listed here. There could be more errors listed because very often in a more complex piece of code, one error could lead to another error, and so on and so forth. That doesn't mean there's multiple errors in your code. It just means that error is getting passed through the whole code. But what do you see here in line 3? You see this arrow here, and this is telling you the first place, basically, where the code broke. So it's going through, it's saying example object equals 2 plus 2. That's fine, I can calculate that. Type of that example object, I can calculate that. But then a list of an example object, I can't calculate because int object is not iterable. What does iterable mean? Well, we'll talk about this in a little bit when we get to a list. But basically, that means that it's something that can be counted through. What we can do, though, is we can say example list, and we can use square brackets. And now we don't get that error. And we can print that example list. And now we see something which is still, we still see our 4 there, and we see our square brackets, and we'll talk more about that later. So anyways, that is our first introduction to Python errors. So let's go ahead and get back to our original integer here. And then if we print example object, we still have our 4. Okay, so as I was saying, Python, you can use it as a basic calculator, so you can do different types of operations. One thing to keep in mind is the order of operations. So Python will use the same type of order of operations that is used in that you learned in your high school mathematics. And so basically it will do multiplications and divisions first, and then it will do additions and subtractions. So you can see here with these 2 lines of code, if we run this one without any parentheses, we run this one with parentheses, you can see that the answers are different because it's doing things in order. So it's going to go from left to right, multiplications and divisions, and then it's going to go from left to right, additions and subtractions. So here we have 5 times 6, which is 30, divided by 4 is 7.5, and then 50 minus 7.5 is 42.5. In this case, we're using parentheses to say, well, we want to do this first, divided by 4, so 50 minus 30 is 20, divided by 4 is 5. All right, so that makes sense, or that should make sense based on your own knowledge of mathematics. Again, we've already seen this, but if you run 2 lines of code, both run, but only the last one displays. And the way that you can prove this is by saying A equals 4 plus 4, B equals 3 plus 3, and then we'll say B. So notice first that if I assign both of these to variables and run this section, nothing gets printed out. There's nothing there. But both of those variables exist, because if I say now print B, or I'll just say B actually, there it gives us the value of B. Same thing with A. And if I say print A and then print B, both of them will run and will display. So, and not only that, but actually I can do this in other code cells. Once I run a code cell, the values, I should say the variables that have been defined in that code cell are available to other code cells. So let me just go ahead and add a code cell here, and I'll just go ahead and print A, print B, and there they both are. And I can even come up here now, add a code cell up above the line, print A, print B, and it will still work. So this is something to watch out for when you're doing development on a code. You want to make sure that you occasionally kind of restart the code, and let me show you how to do that. So here, I'll just leave that there for the moment. I'll come up here to this runtime tab, and I'm going to come down here to say restart runtime, and actually I'm going to say restart and run all. So it's going to restart the kernel, and the kernel is basically the instance of Python that you're running. And it's going to re-import all the packages if we were importing anything, and it will rerun all the code cells. So I'm going to go ahead and do this, and let's see what happens. So this is basically going to restart, it's going to clear all the variables, and it's going to go through and try to run all the cells in this program. And let's see how we get. Aha! And here is another error. So again, whenever you encounter an error in Python, first find the main error, which is usually printed last, and then let's work backwards from that and see what the problem is. And what do we have here? Name error. And you can see the error names can be very helpful. Name error in this case, before we had a type error. Name A is not defined. And you say, well, what in the world does that mean? Well, it means that somewhere we have a variable A, and in this case it's in this particular cell, because this error is tied to this cell. We have a variable A that has not been defined. That means that there's no place where we've said A equals to something. And because of that, that variable doesn't exist yet, and so Python doesn't know what it is. And you say, wait a minute, a is right here. A equals 4 plus 4. And I just said that once you define the variable, it's available in all the code cells, so this should run. But actually, we haven't defined it yet, because this cell is above this cell, and these cells are executed in order. But before, we first ran this cell, and then went back and ran this cell. And so now, if I go ahead and come here, run this cell, okay, so that has run now. Come back here and run this cell, you can see that now it works. So this is something that you just need to be careful for. I'm going to go ahead and delete that cell. In general, you only want to call variables after they've been defined. So here we're defining the variable, and here we're calling the variable, and so that's going to work well. So if we run this cell and then run this cell, that's going to work fine. And if you come up here to runtime, restart and run all, or restart, just restart the runtime and then go through the cells yourself manually, one by one. Either way, if you've defined your variables first and then call them, then everything will work fine. So that's, again, another thing to watch out for. All right, so division always returns a floating point number. That means that the type of this division, print 8 over 5, and then print type 8 over 5. So now we have a new type of object. This is this divisor, and again, you see that we're able to pass in the expression directly. We don't have to define a new variable here. We could say, a new var is equal to 8 this, and then pass that var variable into print and to type. We could do that, but we can actually just directly pass the expression itself, and it will get evaluated first and then passed into that function. Either way, we're able to see now that this 8 over 5 is no longer a class of int or a class of string, but it's a class float. And float means a floating point number, and that's basically just a decimal number. So when you see the word float, just think decimal. And the reason it's called float is because there are a limited number of decimals that a computer can store. And so this is where you hear things like 32-bit systems and 64-bit systems. This is related to the number of bits of information that the computer stores for a given float. Integer numbers have type int. Ones with a fractional part have type float, as we've already said, and we'll see more about numeric types later in the tutorial. Division always returns a float. To do floor division and get an integer result, discarding any fractional result, you can use the double divide operator. To calculate the remainder, you can use percentage. So this is the modulus operator. So here we go. Let's just see this example. 17 over 3. And in this case, actually, let's do print and then print type 17 over 3. So we're going to look at both in the same cell. So let's go ahead and run this. So here's our floating point number, and you can see class float. And here we're going to do this double division operator, 17 divide 3. And if we look at the type of that, the answer is 5, because of course 17 divided by 3 is 5 point something. And so it just gives us the integer, and you can see that this is now a class integer. So this double division gives you the closest integer. And I should say it's floor division. It's not the closest integer, it is the lowest integer. And then we have the modulus operator, so this is going to give you the remainder. Oh, and now we have another error. And this is great. So this is good practice for you all to see how these errors look like. So you can see I'm running this code, and I code all the time. I make errors all the time. It's not a bad thing. Errors are not a bad thing in Python. And this is something that you should keep in mind as you're doing your homeworks and so forth. Don't get frustrated with errors. They're helping you to write good code. So what's the problem here? So again, we're going to go to the last line. We can also look and see which line the problem occurred in, and I can already see what the problem is here. But let's look at the error. So the error is a name error. Name, and now notice that we don't have a type or a class or object. It says name. And that means it's going to be the name of a variable or something that I've typed. Name, P-I-R-N-T, is not defined. Well, what is P-I-R-N-T? I was trying to write print, and I just had a typo and wrote that other thing. And so I just need to fix that typo. And this error message shows me what word is wrong, tells me what is wrong. It's a name, so it's something that I wrote down. And then it tells me where it is, line 1, right there. So let's go ahead and run that cell again, and now we have no error messages, and now we can see what the result of this modulus operator is. 17 divided by 3 is 15, remainder 2, and so it gives us 2. And again, class int. And here we have this order of operations issue, result times divisor plus remainder, 17. 5 times 3 plus 2 is 17. We can use the double star to calculate powers, and powers are calculated first. So if you want to do 5 to the power 2, 2 to the power 7, star has higher precedence than minus. If you want a negative base, use parentheses. So here you can see it's negative of 3 squared. So if we just take a look at that, that's negative 9. Whereas if you want negative 3 squared, you need to use parentheses. So if you want to do negative powers, it actually will work just normally. So you can say, for example, negative 3, well, let's just say 3 to the negative square, and that will work. And it will also work with parentheses. Okay. The equal sign. Now here's a little bit of a tricky part about programming. The equal sign doesn't mean equals in programming. The equal sign means a sign. And there are some programming languages that sort of take into account the fact that this is a little bit confusing and they use a different symbol. But almost all programming languages use the equal sign to assign something. So it's not saying that width is equal to 20. That's not like a true-false statement. It's an assignment. Width is equal to 20. Height is equal to 5 times 90. Width times height. So if you run this, it's going to assign the integer 20 to width. It's going to assign the integer 450, that's 5 times 90, to height. And then it's going to multiply width times height. And notice here, if we print out, let's first create a new variable called area. Area equals width times height. Print area. Print type of area. That's also a class integer. So the equal sign assigns a value to a variable. If a variable is not defined, then using that variable produces an error. And this is what we've seen before. If we try to print a before we had defined a, we get an error. And so this is what you see here. To fix this, we can just say n equals 3 or something like that. Whoops. And running that cell, we now no longer have an error. Python provides full support for floating point numbers. Operators with mixed type operands convert the integer operand to a floating point. This is not such a big deal if you have not done any programming before, but if you have, Python does type conversion on the fly, so that if you have integers and floating points mixed, it will just automatically convert everything to a floating point. Basically, it forces everything to work. In interactive mode in Jupyter Notebooks, the last printed expression is assigned to the variable underscore. So this means that when you're using Python as a desk calculator, it's somewhat easier to continue calculations. For example, let's say that you're just trying to quickly make some type of calculation. You run through this set of lines here. Tax rate is 12.5%. The price is $100.50. The price times the tax would be the total tax. There's the price plus the tax. And then if we round that to decimal places, then you're going to end up paying $113.06. So you can use Python, although I wouldn't necessarily use it to calculate my tax at a restaurant. You can use it just as a very simple desk calculator if you just need to make a quick calculation, and this underscore variable can be useful for that. And treat that variable as read-only, so don't explicitly assign a value to it. Doing so creates an independent local variable with the same name and masks the built-in variable. So this is an important thing to note right here. If you assign a name, a variable, which already has a value in Python, it's going to override its default value. So let's just try this. You can see this round underscore 2. That's going to be fine. But now let's actually change this and say that round equals 2. All right, so now we've just assigned the value 2 to the word round, whereas before round was a function. And now let's try to use the word round to round something. And if we do that, int object is not callable. We'll get an error. And the reason is because we've assigned the value round the value of 2, and now round can't work as a function because we've overridden the function, and we'll have to actually restart this Python kernel, run everything else up to this point in order to get our round function back. In addition to int and float, Python supports other types of numbers such as decimal and fraction. Python also has built-in support for complex numbers and uses the j or j suffix to indicate the imaginary part. We're not going to be doing a whole lot with these other types of numbers, and so I wouldn't worry too much about that. The only possible exception will be these complex numbers here. All right, so let's go ahead and stop there in this video, and I'll see you in the next video.